Well, the arrival of quantum computers could be even more historic than that. We're now at the initial stages of the next revolution.
We have an increasing number of quantum technologies that are really based on this behavior, the quantum computers being a good example.
Quantum Particle Zeta 9 just did the impossible. It unlocks superhuman potential in the brain by predicting decisions before we even make them. Hidden deep in a high-security science facility, researchers were left speechless when this new particle responded to thought itself. Could this mean the human brain is no longer in full control of its own will? Come with us as we break open this breakthrough that will create a new race of superhumans. When the particle knew first. Let that sink in. A subatomic particle beat the brain to its own decision. The lab folks weren't even ready for that. They were just doing routine brainwave monitoring when suddenly their shiny new Zeta 9 particle started changing its behavior based on what someone was about to think. That's not just strange, that's mind-melting. Before we go any further, understand this. What Zeta 9 did next was far more disturbing than anyone at the lab expected, and this isn't the last mind-blowing twist you'll hear. To test it, they wired up volunteers with those brain cap things that track brainwaves, stuck them in front of screens, and asked them to press buttons when certain images popped up. Regular particles behaved like you'd expect. First comes the thought, then comes the brainwave, then the action. But Zeta 9? Nope. It changed before the brainwaves even registered the thought. The tech caught the shift in the particle before the brain even twitched. Every single time. They thought it was a glitch. It wasn't. They swapped the human for a machine and the weird stuff stopped. Bring the human back and boom! Zeta 9 starts doing its spooky thing again. The pattern repeated again and again. No tricks, no errors. Just plain, unexplainable quantum craziness. Now here's where it gets even more bonkers. Some big brain folks started whispering, what if thought itself is a kind of field, like magnetism or gravity? Yeah, imagine thoughts floating around, invisible and powerful, bending tiny particles around them. If that sounds like sci-fi, buckle up because Zeta 9 might be proof that the mind isn't just reacting to reality, it might be shaping it. They're calling it the thought barrier, and Zeta 9 may have just broken straight through it. Traditional science says the world exists independently of us until we look at it or touch it. But if Zeta 9 really does change based on thoughts alone, even before those thoughts become real, then maybe reality isn't what we thought it was. Maybe we're not just watching the world. Maybe we're building it, one thought at a time. And sure, some people in the science world are freaking out. Others are calling for calm. A few are pretending it never happened. But the data doesn't lie. Zeta 9 did something no known particle has ever done. It acted like it knew something, and not in a smart AI way. In a this thing might be tuned into human minds way. Let's rewind a bit. Everyone knows the old double-slit experiment where particles act like waves until someone measures them. That's basic quantum 101. But the Fermilab team added one major twist: real, live humans making real decisions in real time. They cut out all the usual outside signals. No random electromagnetic interference, no hidden wiring, nothing. Just people in Zeta 9. And the particles still responded early. They even added delays, like the participant would think about pressing a button, then wait a few seconds before actually doing it. Zeta 9 still flipped the moment the thought happened, not the action. And the weirdest part? The brain didn't even know it had made the decision yet. Zeta 9 caught it first. They tried everything to explain it away. Bad sensors, statistical noise, human error. Nope, all tests held up. The effect was real, and if that's true, it means we might be staring down a whole new kind of physics. One where the mind plays by rules we don't even understand yet. Let's talk theories. The wildest one? Some scientists think consciousness might be a real field, like light or gravity, a field that spreads everywhere and touches everything. If that's true, then your thoughts don't just stay in your head. They ripple out like waves, and particles like Zeta 9 can pick them up. Imagine every tiny thought you have actually brushing up against particles and nudging them. That means decisions, choices, feelings. They all have weight. They might actually matter to the very building blocks of the universe. And you might be wondering, does this mess with free will? If a particle knows what you're going to do before you know it, are you really choosing anything? Or is it all just a movie you're watching in slow motion? Yeah, that's the part no one wants to touch. But it's hanging in the air like fog. Some researchers are cool with saying maybe we don't fully understand time or cause and effect. Others are whispering about how this might rewrite how we think about the mind, memory, even the soul. And then there are the ones keeping quiet, probably because they don't want to admit that this tiny particle just flipped their world upside down. But just when they thought Zeta 9 couldn't get any stranger, the clock showed something that changed their minds. A particle that reads your mind. Let's just say it. Zeta 9 is weird. Not just a little weird, like this machine buzzes when I think about cats weird. We're talking full-on, how does it know what I'm thinking before I do kind of weird. Scientists tried to figure this out the usual way, syncing up fancy clocks and checking their instruments, but the facts didn't change. Zeta 9 reacts before your brain even knows what it's about to do. That's not just impressive. It's a giant red flag waving in the face of how we think time and thought even work. Here's what they did. The team used atomic clocks and lined them up perfectly with brain scanners and quantum detectors. Then they watched what happened. The quantum particles inside Zeta 9 started shifting before the person even made a choice. We're talking about a lead of around 200 milliseconds. That might not sound like a lot, but in brain time, it's huge. Usually your brain starts prepping a decision about 300 milliseconds before you even know it. Zeta 9 was right in sync with that silent prep stage, the moment your body gets ready to decide, but before your brain tells you it's decided. This flips everything upside down. If Zeta 9 reacts before your mind is even aware, then maybe time doesn't move in just one direction at the tiniest levels. Maybe the future nudges the present. Or maybe your mind, your sense of self, floats outside of regular time altogether, reaching in to play with particles in a way we never imagined. And if that doesn't leave your head spinning, buckle up, because that was just the warm-up. Think about this for a second. What if your thoughts aren't just electric sparks bouncing around your skull? What if there's a shared space, a kind of invisible cloud of thought that everyone taps into without realizing it? Some scientists have actually been floating this idea for years. Rupert Sheldrake, for example, came up with morphic resonance, a fancy name for the idea that habits and thoughts can echo through time and space. Now, Zeta 9 might be the first solid proof that something like that really exists. This little quantum oddball doesn't just sit back and watch, it interacts. It links up with what you're about to think, which means your ideas, your intentions, your gut feelings, they might ripple out into this bigger minefield and stir up particles before you even say a word. We're not in the land of science fiction anymore. This is starting to look like the cutting edge of a whole new kind of science, and it gets even wilder. If Zeta 9 can pick up on your thoughts before they even reach your awareness, then maybe it's possible to send signals back the other way. Could we actually reach into the quantum field with our minds? Some researchers are now wondering if we could build tools that connect brain patterns to quantum reactions directly. Forget wires, forget sensors. Imagine something that reads the shape of your thoughts and then collapses a quantum state just by syncing with your mental energy. Picture this. You move a robotic arm just by thinking about it. No buttons, no joystick, just pure intention. That's the idea, machines and thoughts tangled up in a quiet dance, reacting faster than speech, quicker than a blink. Not even telepathy, something more real than that. Scientists are exploring ways to use particles like Zeta 9 as feedback tools for advanced AI, machines that know what you need before you even say it out loud. Sounds exciting? Sure. But here comes the part that should make you pause. If machines can detect your intentions before you do, where's the line for privacy? Where does your mind stop being just yours? And if something else is already tapping into this mind-particle connection, something not human, something not from this side of reality, then who else is listening in? These aren't just sci-fi questions anymore. They're ethical bombs waiting to go off. And right when they thought the future was strange, the past brought up something even harder to explain. The first thought was never alone. But the most bizarre twist isn't even about the future. It might be buried deep in our past. Zeta 9 doesn't just respond to grown-up thoughts. It reacts to baby brain patterns too, And not just any baby, we're talking embryos. When researchers compared the patterns of Zeta Nine's behavior to brain scans of human embryos around 10 weeks old, something strange happened. The spikes of brain activity matched the quantum collapse signatures almost perfectly. Let that sink in. The stuff that happens in an unborn baby's brain synced up nearly one-for-one with how Zeta 9 responds to intention. This isn't about some random accident or data blip. The match was too exact. The shape and rhythm of those tiny brainwaves echoed in the quantum dance of Zeta 9. That means we might be looking at a connection between the very start of human consciousness and quantum physics itself. That's not just fascinating, that's paradigm breaking. If true, it could mean that consciousness didn't just pop up one day because brains got complicated enough. It might have been there all along, co-evolving with the building blocks of matter. We've been trained to think the brain built the mind the same way a tree grows a leaf. But what if mind and matter shaped each other right from the start? What if consciousness is baked into the physics of reality? Every textbook tells us the brain is just a supercomputer built by evolution. Get enough neurons and poof, you get awareness. But Zeta 9 is pointing toward a much stranger idea. Maybe consciousness didn't come after biology. Maybe it walked hand in hand with it from the beginning. Maybe the brain didn't create the mind. Maybe it just tunes into something that's always been there, something encoded in the quantum script of the universe. And that throws the whole game wide open. What else have we missed because we assume the brain was the source? What if minds connect across space, time, and matter in ways we can barely imagine? What if reality isn't a one-way street from cause to effect, but a tangled web where thoughts nudge particles, and particles whisper back? Everyone keeps saying life just popped up one day after some random mix of molecules got lucky. But what if that's not the full story? What if there was already something invisible out there? Something so small and weird we didn't even think to look for it, quietly humming in the background of the universe since the very start? That something might be a quantum field. Sounds fancy, right? But think of it like a hidden layer in the universe, like a radio signal that was always broadcasting, just waiting for someone to tune in. Now here's where things get really wild. Life didn't just randomly happen, it tuned into this field. Not by accident, but by design. Not designed from above or some big plan, but because everything is already connected in a way we're just starting to notice. Now enter Zeta 9. This isn't just some tiny speck floating around in space. It might be the actual link between our minds and that weird, invisible world. Not science fiction, real science, but the kind that makes scientists scratch their heads and wonder what they're even looking at. Zeta 9 shows a pattern when it collapses. And guess what? That pattern looks shockingly close to what happens in a baby's brain when it starts building the connections for thinking, feeling, and becoming aware. Let's pause there. Are we saying a random space particle is doing the same thing as a growing human brain? That's the kind of thing that should make everyone pay attention. If the brain's earliest sparks of awareness match a particle collapse, we might be looking at the same force at work in both. Zeta 9 doesn't just float around and react to stuff. It responds to intention. That means it acts like it knows when you're about to think, even before the thought is fully formed. But the part that really surprised them wasn't what Zeta 9 is doing now. It's what it might have been part of from the very start. The signal was already playing. Now you can't tell me that doesn't raise a big question. Are we really the ones thinking on our own? Or are we just tapping into a bigger field? Something that was already thinking in its own way? The brain might not create thought like a factory making toys. It might be more like a radio pulling in songs that are already playing. We don't invent the song, we just hear it. If that's true, then everything changes. It would mean that consciousness, this strange experience of being alive and aware, wasn't something we invented. It's been here all along, hiding in the fabric of the universe, waiting for biology to catch up and finally tune into the right frequency. Think about that for a second. What if gravity, electricity, and consciousness are all just baked into reality, like ingredients in a cake? You don't need someone to invent chocolate for a chocolate cake if it was already in the mix. And maybe, just maybe, our brains aren't the source of awareness, but the tools that bring it into focus. Zeta 9, then, becomes way more than a cool science find. It turns into a sort of fossil from the early days of the cosmos. Not made of stone or bone, but of quantum stuff that carries the same signature we see in human brains. That's not coincidence. That's a clue. Now look at it from another angle. Evolution always gets the spotlight for explaining life. And sure, it does explain a lot, but it usually talks about consciousness like it's a bonus feature that showed up after a few billion years of trial and error. If Zeta 9 has been involved since the start, though, maybe consciousness wasn't the end result of evolution. Maybe it was baked into the system from day one, pushing evolution forward instead of being dragged along behind. That would mean biology and physics weren't just running side by side. They were tangled up from the beginning, growing together. Evolution and consciousness didn't take turns. They danced. One moved, the other moved with it. This flips everything upside down. Instead of thinking we're little islands of thought floating in meat suits, we might be walking antennas pulling from a field that's always been there. Not some woo-woo spirit cloud, but an actual quantum field that responds to biology. And now we come to the big idea. If all of this is even halfway true, we're going to have to rewrite how we think about thinking. Consciousness doesn't sit inside your head like a hamster in a cage. It might stretch across the cosmos, popping up wherever there's something tuned in closely enough to catch the signal. The brain doesn't make this happen out of nowhere. It might act like a booster, a tuner, a translator of sorts, helping the invisible become visible. And Zeta 9 might be the missing part that proves this. That makes it way more than a curiosity. It makes it a signpost. Something that says, look deeper, you're missing the point. The weirdest part, Zeta 9 seems to act before we even think. That means it's not just picking up thoughts like a microphone. It's somehow in sync with intention itself, with the direction of the mind before the mind even speaks. Now we have to wonder, are we in charge of our thoughts? Or is there something in the quantum soup steering things before we're even aware? If the particle reacts to what we're about to think, then what does that say about free will? And here's where the headaches start. This isn't just science now, it's philosophy, ethics, maybe even spirituality, whether you want it or not. If consciousness has been baked into the universe since the beginning, if our minds are riding waves instead of creating them, what does that make us? Zeta 9 might be showing us a thread we've never pulled. Not a thread made of neurons or DNA, but something even smaller, even older, and far more strange. The quantum leap, unveiling negative mass. CERN, the beating heart of particle physics, where researchers have stumbled onto something that could rewrite the rules of reality. A prototype engine that churns out negative mass. Yes, you heard that right. Matter that doesn't just defy gravity, but flips Newton's laws upside down, accelerating backward when pushed. It's like a cosmic prank, and it's got the scientific world buzzing with equal parts excitement and dread. Whispers began leaking from the facility, not about the Higgs boson or black holes, but something stranger. A prototype engine, one that doesn't just ignore gravity, it reverses it. Scientists are calling it the first real glimpse of negative mass. That's right, matter that doesn't behave like anything we've ever known. You push it, and instead of moving away, it accelerates toward you. It's like the universe just cracked a sarcastic grin and said, "You thought you understood physics? That's cute. Welcome to Project Lambda R, an off-the-books experiment so secret, even some of CERN's senior researchers didn't know it existed." Officially, it was about quantum vacuum stability, something that sounds like watching paint dry in 4 dimensions. But beneath that boring title was a dream to bend space and inertia like origami. Leaked internal documents reveal the setup. A sleek, cylindrical chamber, no wider than a kitchen table, its interior walls laced with ultra-thin metamaterials, stuff engineered to twist the laws of light and energy. The chamber is chilled to near absolute zero, making the vacuum inside colder than interstellar space. Suspended at its center, a speck of specially prepared matter floats inside a sea of electromagnetic waves, bouncing around in microwave cavities like lightning trapped in a snow globe. Then came the moment. A gentle pulse of electricity was applied. Nothing explosive, just a nudge. But instead of drifting forward, like literally everything in the universe normally does, the speck jerked backward toward the origin of the force. Cameras caught it, atomic clocks recorded it, every control variable checked out. Dr. Marie-Claire Dubois, the lead physicist, reportedly stared at the data in silence before whispering, "We checked everything. This is real." In that moment, negative mass transformed from a quirky idea in theoretical physics into something tangible. observable, operational. But what is negative mass anyway? Picture this. You throw a tennis ball. It doesn't just stop. It flies back at you before you've even finished your throw. That's negative mass in a nutshell. The idea has been floating around for decades, appearing in the stranger corners of Einstein's general relativity and quantum field theory. Mathematically, it fits. Physically, no one had seen it outside of exotic equations and speculative sci-fi until now. The groundwork was laid by phenomena like the Casimir effect, where tiny metal plates in a vacuum mysteriously pull together, thanks to quantum fluctuations. NASA even toyed with negative energy in early warp drive concepts. But CERN's lambda-r isn't just theory anymore. It's hardware, it's measurable, and it's messing with the fabric of reality. The device's sensors are next level. Graphene-based resonators detect shifts smaller than the width of a proton. Stabilizing it all are high-frequency lasers that keep the quantum vacuum from collapsing. But there's one big caveat. It only works in microgravity. Tilt the chamber even slightly on Earth, and the effect collapses. To solve that, CERN plans to take the experiment to the edge of space, about 30 kilometers up, where Earth's pull begins to loosen. And beyond that, they're floating the idea of putting it into low Earth orbit, with superconducting magnets to suspend the device like something out of a Marvel movie. And here's where it gets exciting, not just for physicists, but for dreamers, explorers, and sci-fi fans. Imagine a spacecraft lined with a negative mass coating. As the ship accelerates forward, that coating pulls back, dramatically reducing the G-forces that would otherwise squash the crew into their seats. Some models predict a 90% drop in felt acceleration. You could be sipping coffee as you hit escape velocity. Now take it further. Combine a regular thruster with negative mass, and you've got the holy grail of spaceflight, propellantless propulsion. You ignite once and the system keeps accelerating, forever powered by physics itself. No more lugging fuel across the solar system. Warp drives? Not quite. But it's a serious step toward technology once confined to fiction. Still, not everyone's popping champagne just yet. Skeptics argue the effect may be quantum noise, a hiccup of fleeting energy fluctuations, too delicate to scale up. Others believe the right resonance could make it stable, turning a quantum flicker into a sustained push. That's CERN's next goal, sustain the effect for a full second. Just 1 second of continuous negative thrust, and we're in a new era of physics. If they can do it, well then, we're not just poking holes in Newton's laws. We're rewriting the manual. But hold on, this might just be the tip of the iceberg. If negative mass is real, what else have we been missing? Can we manipulate inertia? Bend gravity on command? Build machines that surf the quantum foam? For now, Project Lambda-R is still wrapped in secrecy, but the ripples are spreading. The future of propulsion, physics, and perhaps even reality itself just shifted a little. So buckle up. We're not just on the edge of discovery, we might be standing at the doorway to a new physics entirely. And the universe is finally starting to talk back. Retrocausality's riddle. Just when you thought negative mass was wild, CERN's Lambda-R engine tossed in a plot twist straight out of a sci-fi thriller. It seems to know what's coming. During a 2024 test, high-precision sensors caught something spooky. Tiny recoils before the electric pulse even fired. It's like the device was playing psychic, reacting to a push that hadn't happened yet. They ran the test again and again, with atomic clocks double-checking every tick. No glitches, no tricks, just a machine that might be flirting with time itself. This phenomenon, dubbed temporal pre-acceleration, has physicists split down the middle, arguing like kids over the last slice of pizza. One camp says it's a quantum trick, not time travel. They point to the engine's Casimir cavities, where entangled photons zip around, sharing secrets faster than light, but not breaking Einstein's rules, mind you. When the system preps for a pulse, tiny electrical jitters ripple through, and those entangled particles might feel it early, mimicking a pre-signal. Think of it like a cosmic game of telephone. Nothing's traveling back in time, just spooky quantum vibes looking like it. They lean on experiments like the 2012 Delft study, where photons seem to react to choices made later. Lambda-R, they argue, just scales that weirdness up. But skeptics aren't buying it. They demand CERN isolate every wire, cage every signal, and randomize the pulses to rule out sneaky leaks. If it's just electronics talking, the mystery's busted. The other camp? They're all in on the crazy. They say Lambda-R is breaking causality itself, future events nudging the present. It's not as nuts as it sounds. Theories like the two-state vector formalism suggest quantum systems can be shaped by both past and future states, Weak measurements, gentle peaks at quantum systems, have shown hints of this, and Lambda R's sensors might be catching the same vibe on a bigger stage. A 2017 Toronto experiment backed this up, showing entangled particles steering each other in ways that mess with time's arrow. If they're right, the universe might be time-symmetric, with the Big Bang and some far-off cosmic finale holding hands across eternity. Philosophers are sweating, wondering if free will's a myth if tomorrow's choices shape today. Tech-wise, retrocausality could birth machines that predict failures before they happen. Think cars dodging crashes before the brakes fail. But there's a catch. No one sent a clear signal back yet. Without that, it's a cool anomaly, not a time machine. Other ideas float around. Superdeterminism says it's all scripted, with hidden variables rigging the game from the start, no time tricks needed. The many worlds crowd thinks parallel universes might be leaking echoes into ours. A tamer theory blames a jittery vacuum snapping back to normal, pushing the mass early. Critics, though, wave the red flag. It could be noise, bad math, or a fluke. They point to physics' graveyard, faster-than-light neutrinos, cold fusion flops, and say Lambda R needs a second lab to back it up. CERN's not sitting idle. They've locked the data in a vault, with experts from Caltech and Vienna sniffing for errors. Blind tests with random pulses are in the works, aiming to shut down human bias. The community's buzzing. Optimists see spacecraft dodging storms before they form. Realists see a mirage. The next 6 months are make or break. If Lambda R's for real, it's not just physics. It's a glimpse into a universe where time's a two-way street. Space-time on the brink. Hold on to your hats, because Lambda R's latest stunt might be its wildest yet. It's not just bending mass or teasing time. It's strumming the fabric of space-time like a cosmic guitar. In February 2025, a test at near-zero gravity revealed the engine's negative thrust oscillating, flipping between forward and back at a screaming kilohertz pace. That rhythm matches theories of a space-time bubble, a pocket where reality itself vibrates. If true, CERN's built the first space-time resonator, and we're teetering on the edge of a cosmic overhaul. Leaked documents hint at darker stakes, an Omega singularity test that nearly went haywire. Budget lines mention stability systems for a mass phase collapse, a polite way of saying they might have birthed a micro-black hole. In December 2024, an EU audit screamed phase anomaly and urged CERN to slam the brakes or risk a quantum catastrophe. Whistleblowers say tests were paused for 3 months, while engineers rigged magnetic traps and photon cages to tame the beast. What's the Omega singularity? It's when negative mass gets too frisky, collapsing into a point that warps space-time into an event horizon. If controlled, it's a game changer. Think wormholes on demand, zapping messages across galaxies, or stepping through to Andromeda. But if it slips, a runaway singularity could gobble the lab, the Alps, maybe more. No wonder CERN zipped its lips tighter than a vault. The resonator's no less mind-blowing. That oscillating thrust suggests gravitational waves, ripples in space-time locked in sync. Harness that, and you've got communication faster than radio, propulsion that laughs at fuel tanks, maybe even shields that bend time around a ship. But destabilize it, and you're poking holes in reality with no clue what's on the other side. Theories for practical use are tantalizing. Negative mass shields could make high-speed travel feel like a stroll. Runaway drives might send probes to Alpha Centauri on a whim. Time dilation hints, clocks inside the chamber lagging, suggest localized time control, like pausing a battle to rethink strategy. But scaling, it's the hurdle. Quantum flickers might stay too brief for starships unless CERN cracks continuous thrust. The risks are existential. A misstep could unravel space-time or spark surveillance tech that predicts your moves before you make them. Philosophers fret. Are we puppets in a time loop play? Optimists dream of starships. Skeptics see another cold fusion flop. CERN's pushing forward. MIT and Tokyo are building rival rigs, and X-ray scans might map the engine's heart. If Lambda R sings, it's a symphony of mass, time, and space. If it crashes, we might all feel the echo, the future of space travel. If Lambda R's space-time vibrations are the opening chords of a cosmic symphony, the next verse could propel humanity to the stars. The engine's ability to toy with negative mass and ripple reality itself hints at a future where space travel isn't just faster, it's a complete rewrite of the rulebook. Warp drives, teleportation, and galactic road trips might sound like sci-fi dreams, but CERN's work is laying tracks for a revolution that could make them real. Negative mass is the golden ticket. Pair it with a regular engine, and you've got a runaway drive. a ship that accelerates endlessly without guzzling fuel. Imagine a probe zipping to Proxima Centauri in years, not centuries, sipping only a spark of energy. Or picture negative mass shields wrapping a starship, letting crews blast through space at mind-bending speeds while feeling barely a jolt. No more astronauts strapped in like sardines. They'd be strolling the deck, sipping tea as the cosmos whizzes by. Then there's the warp drive vibe. Lambda R's space-time oscillations echo theories like the Alcubierre drive, which bends space to shrink distances. If CERN can amplify those ripples, we might surf space-time itself, hopping from Earth to Mars in minutes. The catch? It needs stable negative mass by the ton, not just quantum flickers. Engineers are eyeing orbital tests to scale it up, dreaming of ships that dance through folded space. Teleportation's the wild card. The Omega Singularity, those micro black holes, could be baby wormholes, linking distant points like cosmic shortcuts. If controlled, you might step through a portal in Geneva and sip coffee on Titan by lunch. But it's risky. One wrong move and you're not teleporting, you're unraveling reality. CERN's magnetic traps are a start, but mastering wormholes is like taming a dragon. The road ahead is bumpy. Scaling negative mass for starships needs tech we don't yet have, and skeptics warn of flops like cold fusion. But if Lambda R delivers, we're not just exploring, we're colonizing, communicating, maybe even meeting neighbors across the galaxy. The stars aren't just closer, they're calling. Lambda R's journey from negative mass to time-bending echoes, space-time ripples, and starship dreams has dragged physics to a thrilling cliffhanger. It's not just a lab toy, it's a dare to rethink everything. Negative mass flips Newton's playbook, promising ships that glide without fuel or shields that laugh at G-forces. Retrocausality teases a universe where tomorrow whispers to today, hinting at machines that predict chaos before it strikes. The Omega Singularity and its vibrating reality bubble flirt with wormholes and warp drives, offering shortcuts to the stars. And space travel? It's no longer about crawling. It's about leaping across galaxies, maybe sipping coffee on Mars by noon. We've just scratched the surface of what negative mass could mean for science, space travel, and maybe even reality itself. If this blew your mind, imagine what's coming next. Make sure to like, subscribe, and hit that notification bell so you don't miss our next deep dive into the unknown. Got questions? Theories? Drop them in the comments. I'd love to hear what you think. Until next time, stay curious, because the universe is only getting weirder.